Hello, Assalamu alaikum. Good morning, everyone. Welcome to the class. Um, tomorrow you have a mid-lab exam. But what about the quiz? I forgot about the quiz number 3. So when it should be? I said, yeah, okay, thank you. When it should be? Is it today or I mean next week? What we discussed in the last class? I think. This week or next week? Next week. Okay. Yeah. Okay. I was a bit confused. Yeah. Okay. All right. So, okay. So this week actually just only we have mid-lab exam. So tomorrow, inshallah, 2 o'clock. All of you come at 2 o'clock. So it will be done together. So yeah. So this chapter is a little bit left. So let us go. The system is a bit slow. I'm not sure what happened. Basic information, all the experiment 2, from experiment 2 and 3, so it's not like long information, long code or long, it should be basic understanding. You should be clear about the basic understanding. So basic information, but experiment number 2 and 3. So there is nothing will be difficult exercise. It is just for your understanding. In the lab, actually, we did many things, but yeah. So all the basic information. Okay. So there is nothing. Okay, so we were in this slide how about the delay loop subprogram. So we already got it how to generate the 1 megahertz. Sorry, how to produce 10-second delay, how to make 1 second delay, something like that. So this is our base calculation. I mean, if we have a 4.915 megahertz. 4.9152 megahertz, like the yeah, the, the trainer board that we will use in the lab. You will use in the lab. Its frequency is 4.9, but in general, normally we can say it is 5 megahertz. If it is a 5 megahertz, calculation is little bit different. So then, what should be the n value for 100 millisecond? The n value in the last class we calculate is 27,777. It's very easy to remember. 27,777, something like that. But if it is 4.9152 megahertz, is the value of n we should put here. The value of n we should put here is 27,300. Okay, so yeah, it is clear, right? So and then if we need more, more more delay, like we need 15 second, or we need like a 25 second, 15, so the number will be very big. So this number, it is not possible to load on the CX, because what is the maximum value of CX? 2 to the power 15. So because it is a 16-bit register. Okay, so 2 to the power 15, what is the 2 to the power 15? So if you check on the calculator, what is the power 2 to the power 15? 2 power 15, it's like 32,768. So maximum value is 32,000. So you can see that it's already 27,000 for 100 millisecond. So it will be very big for 1 second, for 10 second, for So then actually what actually we can use, another loop outside this loop, outside this subprogram. We can use another loop like move bl comma something. Yeah, can you remember that? That is clear to you? We discussed in the last class, right? Okay, so yeah, this is about the delay subprogram. Let us go for more other topics. It's about string instruction. You know, we already know what is called string. What is string? Can anybody tell me what is string? Set of data. Very good. Okay, a set of data. So so if we have a set of data, it may be 5 data, 6 data, 10 data, 100 data. Yeah, so it can be, you know, like array. Yeah, the array is similar idea. Array, you already know array in C programming. So array string is quite similar actually. So it's set of data. So array can be actually multidimensional. It can be. So it is one dimensional. Anyway, so a string is a set of data. When we have a long set of data, so we can use some special instruction to to make the things easy. Because you know, like if we have a 10 data, we take one by one. It's not, it's taking long time. Okay, so for example, if you can remember in a basic subprogram, basic program like a move a block of data from one memory location to another memory location, what actually we do, or we did that we take one data, then we copy it to the new memory location, then take the next data and the next location, and so on. So it's a long time. If it is a 100 data, so it's a 100 times slower it will be. Okay, so then there are some special instructions that actually make the things faster and make the things easy for us also. So one of the instruction, it is called move s, move string, mov. We know that mov for move, but mov at the end is it for string. So move movs, the mnemonics is movs, and we can say move string, and we can write it this either one of the two way, like move string as a byte, b for byte, or move string as a word. Okay, in these two way we can write it. So MOVS is the main thing, but at the end we can write B or W. So then this one of the two format we have to use. So main mnemonics is MOVS. Okay, so move string as a byte. So that means this thing actually help us to move from memory location to memory location. But for single data we cannot do it. So yeah, if you can remember, okay, so let me write it. Okay, so like for example, move si comma offset x. So this is for example the old data location, move si comma offset x, and new location is y, move di comma offset y. So this is the new location, the name y. Now what actually we can do, we take one data from this old location and copy it to new location, something like that, right? So like move okay. So if we write it like that way, that if it is allowed or if if it does work, then it is a very good. Like if take that take memory location, the source. Both operand are memory location. Okay, So then it is very easy actually, but it doesn't happen. It is not allowed. So, or it is not here. From memory location to memory location, we cannot copy single data. But so that means, that's why you can remember in one of the example, I mean one of the exercise in homework 2 or homework 1, I think probably that something like that. So memory location, what was the I mean what is the mistake in this kind of instruction? So mistake is that it cannot allow to copy memory location to memory location directly. It you have to use I mean you have to do one more step, like so like you have to use like move any register. You have to use any register. For example, we can use ax as a word. So if anyone, like because the memory location data is 8-bit, so 8-bit register, for example al or ah, whatever it is, move al comma square bracket si, okay, and then move square bracket di di comma al. So just two more, yeah, instead of one line we have to write two more line. So that means we have to use any register. It's not necessary that accumulator you have to use, any register you can use. So move bl comma square bracket si, you can write move al comma square bracket, and then move the square bracket di comma that register, like here it is al, so al. Okay, so this is the way actually it works. So that means if for a single data copy from one memory location to another memory location, we have to use a register. But like if for a string operation, we can write something like that. I mean it actually we don't have to use a var. I mean directly we can do something. We will see the example, and we can copy from one memory location to another as a byte. That means one memory location data to another, or we can write, but we can copy it as a word. That means two memory location data, so 2 byte as a word. So move string as a word. Okay, so let's see more. Then compare. There is another instruction. So CMP, we know it compare. S for string. So compare string, and we can also do it as a byte, B for byte, and W for word. We can do it. And what about the SCAS? So it is actually scan string. So also here we can do it as a byte, as a word. Now, okay, so these two are quite similar, but they have the difference. We'll see it. We'll see. And these two also similar type of I mean operation, but a similar application, but they have the difference. So one is called LOD for load string, and STO for store string. So LOD, again we can use it as a byte or as a word. And store string, this is also we can do it as a byte or as a word. Okay, so right now just look at the name. What does MOBS and what does CMPS? And just get the name. Then we'll see. We'll discuss with the application. That it will be clear. And also, these two instruction, a special instruction related to the flag, also we will use. One is called CLD, and this is, I said at the beginning of this lecture, of this file, the CLD, clear direction flag, clear DF means directional flag, and STD is set directional flag, and we will use these two instruction related to this string instruction. So that means how many string instruction we can see here? We have 5 string instruction, special type of instruction that we can use related to the string data, set of data. All right, and when actually we use this string instruction, we have to use these two instruction also. CLD, one is for CLD and one is for STD. One is one means CLD means clear direction flag, STD means set direction flag. Okay, now it's time to see the application, then it will be clear. uh, it looks slow. So can you hear me? Hello, can you hear me now? Okay, so actually, I think the blackboard, yeah, is very slow today. I don't know. So maybe it's I mean, use. I mean, a lot of users are around. So, but it didn't happen in the last few weeks. So very slow actually. The pace takes. I mean, it takes a lot of time to load a page. Anyway, so in the last class, I mean, in the I mean, before the disruption, I said that we have some instruction that are related to the string. So it's time to see their application. So like move, compare, and scan string. Move string, compare string, scan string, they are similar to each other. I mean close similar, not fully similar. They are, I mean, they have the difference, but quite similar application. And load and store, they are quite similar. Okay, let's see example. Can you remember we use an yeah, simple program that we use, I mean, to copy few data from one memory location to another memory location. So these two line is initialize the data segment, you know. So this one is same as like, you know, like at the rate of data. What we use at the rate of data, at the rate of data, for example. Okay, it's not a full program. It's just a part of, I mean, just on the code segment here. Okay, so this is for initialize the data segment, and then this line actually initialize the extra segment. So in data segment and extra segment is the same here. So I think not necessary. This line is not necessary. Okay. So main thing is like move si comma. So si comma this one is the address. So si comma, for example, offset address. O offset offset address. Sorry, offset, just only offset x. Move si comma offset x. O double f set offset x. And this one is move di comma offset y, for example. Offset y. So y is the new location, x is the old location. Okay. And then how many data we have? For example, n data. N may be 10, 20, whatever it is. Move cx comma n. Now you can see we use the CLD. CLD for clear direction flag. And then move string as a byte. Move string as a byte and then loop in this label. So this label is, for example, nxtpt. So whatever it is named, doesn't matter. If you write L, doesn't matter. Loop this line. So that means it will, again, it will do the move string as a byte. Move string as a byte. How many times it will continue? So it depends on the counter value. And counter value depends on how many data we have. 10 data, 20 data, whatever it is. So this like that. And then end. So halt or end, doesn't matter. So for example, this is end, because we normally use end, not halt. So it's the same application. End. So look at here, why actually we use the CLD. So CLD actually clear direction flag. If it's clear direction flag, then data moves from lower memory location to higher memory location. Okay, look at here. This is, for example, our memory block. And part of the data segment is here. Okay, so under the X we have this data. Okay, we have some data. For example, we have like a byte size data. So I'm just putting XX, for example, XX. They are the data. It can be anything, right? 10, 25, whatever it is. So these are the data. Okay, so with the name X for memory location X, with the variable is X. So what actually we do? That's why we write move si comma offset X and move di comma offset Y, because the new location where actually we copy this data. Okay, so then if we have a like 10 data, if we have a 10 data, so that instead of n we can put 10, move cx comma 10, and then CLD clear direction flag. So it allows data from lower memory location to higher memory location. So normally this is the lower memory location data. Then the next one is there. So that means you are moving higher from lower memory location to higher memory location. So CLD, it allows to perform the string operation from, or it allows to access the string data from lower memory location to higher memory location. So and also copy of the new memory, during the copy into new memory location, we also do the from lower memory to higher memory location. So this one is fast, then this one is, then next one, and so on. All right. So this is the way actually CLD, I mean CLD actually helps with the function of CLD is to access the string data from lower memory location to higher memory location. Is that clear? This one is okay? Yeah. So again, I am repeating. So it's like a block program. This one actually very well-known program. We use many times for different types of instruction. I mean, we use this program as an example. Okay. So here again we are using again to see the example of application of move string as a byte or move string as a word. Okay, so first two line is to initialize the data segment. So initialize the data. How can we initialize? Move ax comma at the rate data. Instead of this one, okay, take it easy at the rate data, and then move ds comma x. We don't need the extra segment. Okay, forget about this lines. Third line, and then old memory location, old location of the data is x, for example. So move si comma offset x. New location with the variable name y. So move di comma offset y, because si and di you have to set it first. Okay, and then counter, load the counter. How many data you have? 10. Okay, load the counter cx comma 10. 100, 100. Okay, then we have to use the how actually we'll move on from higher memory location to lower memory location, or lower memory location to higher memory location. So normally we do, because normally we do from lower memory location to higher memory location. That's why we use CLD, clear direction flag. And then next line is move string as a byte. You can write also word also. That will be little bit, that will be faster. Move string as a byte. Okay, then loop this line again. So if it is for example, this one is just L, the label L, you can write loop L. Okay, so and then end. So how many times the loop have to continue? 10 times or 100 times. It depends on the size of the data. Is it okay? So is it clear that what is the application of move string as a byte or move string as a word with the use of CLD or STD? First two line is to initialize the data segment. Initialize the data segment. Move ax comma at the rate data, and move ds comma ax. It is very common, right? We use it in the lab. Then move si comma offset x. X is the old memory location. Okay, so under the variable x, so x under the variable name x, we have few data. So these are the data. Any data it can be. So we have 10 data, for example, here. So move si comma offset x and move di comma the new location offset y. So for example, this location is the new location. We want to copy this old data from old location to the new location. Then move cx comma the number, how many data we have for 10, 20, whatever it is, just put the load the counter with this value. For example, 10 data, move cx comma 10. Now I mean, we can do two way. This is string operation. We can do two way. One is lower memory location to higher memory location. That means take this data first and then this one, then next one. Or we can start from higher memory location data to lower. Like we take this one first and then next one, and then last is the is the lowest memory location. So we can move from higher memory location to lower memory location, or we can move from lower memory location to higher. So we can move this way, or we can move that way. Is that clear? So if we use CLD, that means we do from lower memory location data to higher memory location. That means we are moving this way. It's okay. And move string as a byte. So that means as a byte means that means take one data, this memory location data, then take it and save it here. The next one, take it and save it here. Copy it, save it here. So this is the way. And then so move string as a byte and loop. We use the loop instruction also here. Loop L. So L is what? L is the label of this name, for example. L is move string. So that means these two line, the loop continue 10 times or 100 times, depends on our data. It will continue, and at the end it will finish end. Okay. Okay, so now so what is the what is the use of when actually are CLD and STD instruction use? So CLD to and memory location. Okay. So CLD, it allows to clear direction flag. So it means actually clear direction flag. So CLD means clear direction flag. It allows to access the string data from lower memory location to higher memory location. And what is STD? STD means set directional flag. It allows to, okay. Okay, so I mean the system is like that. So yeah, it's lagging. Okay, so you cannot see what I am writing. Can you see what I am writing? Okay, can you yeah, can you see what actually I wrote here? Yeah, okay. So this is one is clear direction flag and one is set direction flag. So we got it now. Okay, so this is clear, right? This example is clear, right? Move string as a byte or move string. So move string yeah. So let us go to the next slide. Okay, so here actually you can see that compare string as a byte or word or a scan string. So this one is compare. Okay, so compare string as a byte or word and then scan string as a byte or word. What is the difference between these two? Let us see it. So move. So again, this two line is same. Okay, forget about this line. So this one is like a at the rate data. Okay, so move ax comma at the rate data, move ds comma ax. So that means initialize the data segment, and then move al comma 05. So that means al is now 05 or 5 because it's a decimal number. And move di comma a000. So initialize the di in that destination index register, and cx is 05 0f 0fh. That means 15. Cx is loaded with 15. Okay, and then it is use CLD. So CLD means clear direction flag. So that means it will do the string operation. For string operation, it will access the data from lower memory location to higher memory location. Okay, and then SCA scan string as a byte. So what is the difference? What is this thing? So scan string. So here is the explanation. The scan string is similar to compare string. So scan string and is quite similar, but they have the, however, it compares. So it means the scan string, it compares the byte or word element of the destination in string at the physical address derived from DI and DI and ES to the content of DI and ES. I mean D and not ES actually, DS to the content of AL or AX respectively. So okay, so I am writing it again. So what is the compare string as a byte? Okay, so let me write it, then it will be clear. Okay, I'm writing here. So move string. So what it copies string data from one memory location to other memory location. Okay, this is move string. This is we already have seen it, right? Move string as a byte or what doesn't matter. So it copies string data from one memory location to another memory location. But what is scan? As okay, first of all, I can write compare CMPS compare string. Oh no, string. Oh no, not this one. Compare string will later. Load string. Accumulator. Okay, so load string, it copies string data from memory location to accumulator. So accumulator may be AL or AX, right? 16 accumulator. And then what is store? Store. What is the how to? Okay, let me open the slide. STOs. Okay. Yeah. So a store string. Sorry, what do you mean? Okay, so the yeah, so this yeah, write it in English. Otherwise, how do I understand? So let's see. These three are, I mean, similar type of instruction: move string as a move string, load string, and store string. So MOVS, so that means it copies string data from one memory location to another memory location. This is already we have seen. And load string, it copies string data from memory location to accumulator. So that means not memory to memory. From memory to accumulator, it may be AL or AX. Okay, as a byte, that means AL, and as a word, AX. And store string, STOS, it copies string data from accumulator to memory location. All right. So these three difference is clear. Is it okay? Is it okay? Can you hear me? Okay, so this is about this three instruction. Okay, and what, so now it's about that scan string and compare string. So scan string is, So let us write that one also. So compare C and P, compare string. Compares compares. Okay, so compare string, it compares string data in memory with another string data in memory. So that means memory data. Memory data is memory string data in one location. I mean, yeah. So both compare the string. So string data in memory with another string data in memory. This is the compare. And but what about the scan? And string. Okay, so here actually scan string, it compares string data in memory with accumulated data. So can you get the difference between this group? I mean, the first group, it has a three instructions: string instruction, move string, load string, store string. What is the difference between these three? And what is the difference between these two? Compare string and scan string. So compare string, it compares string data in memory with another string data in memory. So memory, so it's comparing string data into memory location. But what about the scan string? Scan string, it compares the string data in memory with accumulated data. Okay, let's see the example here. So then first two line is for move ax comma at the rate data. So that means initialize the data segment, and then move al comma 05. So that load al comma 05. I mean al is loaded with 05. Then move di comma destination index. So di is loaded with a000h. Okay, and cx is loaded with 15 or 0fh. All right, and cld is for lower memory location to higher, accessing data from lower memory location to higher memory location. And then scan string as a byte. What does it mean? It means it will take the string data from the it will compare the string data in memory with the accumulated data. Okay, accumulator is 5. So what is the string data? What is the location of the string data? It can find it from base address, uh, uh, okay. Let me verify it one point. Scan string. So okay, so all right, so that means this line, actually the third line, don't ignore this third line. Okay, so third line is this third line is okay. So yeah, so what is, where actually the string in memory location, in which memory location the string data is there. So it can get it from So third line also extra segment is initialized with this third line, move es comma ax, and this is the offset address. So this is the base address. It extra segment is holding the base address, and the location of the data is defined by the di. Di is a00s. So that means this is the location of the string data. Okay, so that means 15 data from A000 to A00 So 15 data, it will compare with the 05. If so, and if not equal, it will come again. So loop not equal. This is also we have seen loop not, it will compare again and again. So how many times maximum? If it gets any data, any string data, if it is 05, it will be out of the loop. And if it is not 05, and so how many times it will compare? 15 times. Okay, so let us see the explanation. The string instruction is similar to compare. Scan string instruction is similar to compare string. However, it compares the byte or word elements of the destination string at the physical address derived from di and es. Sorry, es, extra segment and di. So it will then it gets the location of the string data with the accumulator. Accumulator, it can be AL or AX. If it is as a byte or as a word. Okay. Here 15 memory location in extra segment starting from offset A00H are compared with accumulated data 5. If any value of 5 is found, loop will end. Otherwise, it will continue. Okay. So this one is okay. Do you understand this program sequence? I mean the use of a scan string. Do you have any question here? So this program sequence, I mean a few lines of program with the use of a scan string. Yeah, is it clear? Okay, so is that okay for other guys? Yeah, is that okay? I can go to the next slide. Okay, so then yeah, what I said, this one is, you can see load string, load and store. These two already I have written. So load, actually, yeah, let me see the explanation. Load string and store string are specifically provided to move string elements between the accumulator and memory. So load string as a byte, it loads a byte from a string in memory into accumulator. This is I already have written. So when I write something, actually, so you should note it down. So that makes you things easier. So load string, byte or what, doesn't matter. So load string means I mean it copies memory string data from memory to accumulator. And what about the store string? As a byte or whatever it is, store string means it stores string data from accumulator to memory location, okay, location in memory. Okay, so now look at here, move ax comma 0, move again this this three line is to initialize the destination data segment and extra segment. Okay, we have written it here, doesn't matter. Move al comma 05 and di I mean the offset address for extra segment is 0a00h, okay, for example, and cx comma 15 or 0fh, and cld, clear direction flag, and store string as a byte. So what is happening here? So it's happening here that store means actually accumulator data will be data, string data from accumulator to memory location. So which memory location it is going? So accumulator data is 05. Okay, it is fixed. Okay, so that means 05 it will be loaded for, let me draw it. So memory block, for example. So for example, we have, this is the extra segment. So the memory location in a logical format, ES colon A 0 0 0 A00S, because DI is assigned A00S. That means A05 memory data, a string data from accumulated to memory. So that means 05, it will be loaded 05 in this memory location, 05 again. So how many times? How many times is 15 data. So all will be 05. So that means we can say that the accumulator string data from accumulator to memory. We can say like that. So like that. Is that clear? Is it okay? And okay. So this is the use of store string as a byte or what, doesn't matter. This is the way it works. Okay, now we can see some more string instruction. This is called REP. REP means return. Repeat. Sorry, repeat. REP, repeat. Repeat. We can use it before like move string or store string, something like that. Or the string instead that actually you use, we can use the REP to together with it. Let's see this example. Let's see this example. Move AX comma 0, move DS comma X. So the previous one, okay? Just the previous one. Initialize the data segment and extra segment AL comma 05 and DI comma 0 and move CX comma 15 or in hexadecimal 0FS. Then CLD, clear direction flag. Why actually we use it? From lower memory location to higher memory location, accessing data. Okay, then we can instead of few line, we can use just one line. Repeat. It repeats store string as a byte. So that means it will repeat the things. It will repeat the store. It will repeat the store operation. A store string operation as a byte. How many times? Based on the counter value. Is that okay? Is it okay? So that means we can use the repeat instruction with the move string or store string. Okay, but we can use also this repeat equal or repeat 0 with the compare, because during the compare sometimes we compare they are equal or not equal. So repeat until if it is equal. Okay, until it is equal, or repeat until it is their difference is not 0. Okay, it's something like that. And this one is repeat not equal, repeat not 0, the same thing. So we can use the repeat equal or repeat 0 with the compare or scan instruction, because they are they are similar compare operation. Or we can use repeat not equal, repeat not 0. So this repeat instruction is okay, right? Let's see, repeat 0. Okay. CLD, we use this instruction CLD before initialize. It can, we can use the CLD also here. Here also we can use the CLD here before the string instruction, or we can use it in the middle or okay. So CLD for accessing string data from lower memory location to higher memory location. Okay, so now it's about initialize the data segment. These two lines is to initialize the data segment. Okay, so we know it how to initialize, and these two line is to initialize the extra segment. Okay, so we can do it now. Move cx comma 20h. So this is the hexadecimal value. I think probably it will be 32. 20h, if you convert it to the decimal, it will be 32. Okay, now move si comma offset x. For example, master means actually I mean the old data location x, and move di comma offset copy means the new location with the name copy. Okay, y, for example, this is y. Okay, and then we normally so then we write the CLD. So CLD before at the instead of beginning we can use it here. It is better, CLD in this line. Okay, then what actually we did move string as a byte, and then loop. We use the loop. So instead of that we can write repeat until 0. Repeat until I mean repeat z. Yeah, repeat until 0. That means the counter value. And okay, let me check it. Why actually repeat z we use here? Repeat z actually we cannot use with repeat z. We cannot use with the move instruction, move string. So repeat z actually it should be. I think it is a mistake here. It should be repeat only, not the z. Okay, so repeat move string rep. This z it is a I mean mistake actually, definitely. Repeat move string as a byte. So it will continue. It will continue based on the counter value. Is that okay? Hmm? It's okay. Do you have any question here? So you got the mistake, right? This z should not be here. Z is for zero flag. It will compare the zero flag. So zero flag actually it's about the compare related compare instruction, like compare or scan. But here move there is no. It's just REP. Not it should not be Z. Z should not be here. All right. Do you agree with me? Hmm? So can you hear me? Okay, so again I'm making it again I am reviewing it. So this two line is to initialize the data segment. We know how to initialize the data segment. Move x comma we can write it like at the rate of data. Okay, at the rate of data, or we in a full segment definition format we can write the name, right? So whatever. Okay, at the rate of data. Okay, and these two line we don't need it actually. Extra segment is not necessary here. We don't need these two line. Okay, forget about this two line. And then move cx comma the string size is like, for example, 32. 20h is actually in a decimal format, it will be 32. And move si comma offset x. It's like a old location. For example, this one is x. And move di comma offset new location y. Okay, and then we can write this CLD instead of here we can write it here. Actually, I mean, if we write it here, that will be more significant, more better. CLD, that means lower memory location to higher memory location. Then actually previously we write move string as a byte and then loop. But here actually instead of loop, we can write repeat, REP. For repeat, no Z. Z is not applicable here. Actually, I think it is a type mistake actually. And REP, move string as a byte. And that's it. And then finally it is end. End. Do you have any question here? So there is no Z here. Is that clear? So, so the explanation. Let us see the explanation. Execution of repeat move string as a byte moves a block of 32 consecutive bytes from the block of memory location starting at offset here instead of master, for example, X. Or simply I think I already said you can write that way also, move X in the move your offset address offset X, yeah, X to a new location or to a location at of offset address Y. Yeah, so no need of extra segment, data segment. I will make it easy. Okay. I mean, I think it's not necessary. It can be in the same segment, a data segment. So, okay. So the thing is, let us make it easy. So execution of repeat move string as a byte moves a block of 32 consecutive bytes, 32 string data or string bytes. Okay, consecutive, it comes as a consecutive because they are next to each other. In the memory location, they 32, no need of consecutive byte. 32 bytes, a block of 32 bytes from the memory location, with offset from the memory location offset X. Okay, offset X, because master, instead of master we can write it easy way, offset X to a location with offset Y, offset Y, offset Y, just Y. Okay, that's it. Is it okay? Clear? Okay, so it's about how to use this. Okay. Let me write it again. Actually, I think probably it will be better. I mean, move X, comma, the rate data. Move PS, X. Okay, and then move CX 20H. Okay, and then move XI, comma, offset X, and then move I set Y. Okay, and then repeat move string as a byte. Okay, and then end. B, and that's it. So that means we can write this way also, the same thing. You can also write, do the modification according to me. So move ax comma at the rate data, move ds comma ax. That means initialize the data segment and then set the counter value. What is the string size? For example, 32. So in a 32 decimal number, we can write it to 0h also. And then move si comma offset x, the old location, and di comma offset y, the new location in the data segment, and repeat move repeat move s for string as a byte and then end. So that means we don't have to write the loop another further one more instruction. Is that okay now? Clear? No need of, no need of this one. Is that okay? All of you clear? Yes, okay. Uh, all right, okay. So we have seen that we can use like in addition to normal instruction, there are some special type of instruction. So this chapter basically about that thing, that one of the special type of instruction is related to the flag. I mean these instructions like CLD, STD, and CLI, STI. So these are the things, especially the CLD and STD. We have to use for string data quite often. And also also some instruction like we have seen the loop is some loop instruction, and also we have seen some string instruction, a special instruction related to the string. Okay, like move string, load string, and store string. They are similar, but they have the difference. Okay, so move string means string data from one memory location to another memory location, new memory location. I mean copy string data from one memory location to another memory location. And load string, it means that copy string data from memory location to accumulator. Okay, and then store string, it means the string data from accumulator to memory. All right, this is like that. And what about the also we have two other string instruction. One is compare string, another one is scan string. So compare string, it means they compare the memory string data in memory location to another string data in another string data. I mean again, so compare string data in one memory location with other memory location. So string data, so both are string data, we can compare them. Okay, so this is one way, and there is another thing is scan string. So it means that compare the string data in memory location with the accumulator. Okay, so they are clear, right? The definition is clear. I already wrote the definition, right? So I hope it is clear. Okay. Any question do you have here? Okay, now it's about the new point. It's called macros and procedure. Okay, so what is procedure? Already we discussed that what is procedure or subprogram, right? We have seen it, but So what is macros? Macros actually in a C programming, actually, if I can give the example, I mean, compare it with the C programming, then it will be more better. I mean, it will be easier for you. Macros is like a user-defined function, like, sometimes, in C programming, we may have some user-defined function. We can use them in our main program. And procedure or subprogram, it is very clear. It is already we discussed, I mean, few lectures back, but again here. So let us see the definition. Whenever we need to use a group of instructions several times throughout a program, two ways we can avoid writing the group of instruction each time we want to use it. So one way is to write the group of instruction as a separate procedure, and we can then just call the procedure whenever we need to execute the group of instruction, as you have seen it before, or like, yeah. So like, if you can go back here. Yeah, subroutine or subprogram or procedure, or like, this is our main program and this is the subprogram. So when actually we call the subprogram, I mean, when actually we need the subprogram, how can we do it? Like, we can use the call subroutine or subprogram, something like that, or procedure. Call subroutine A. So this is the A. So that means it come here at the beginning of the subprogram, and when it finish, we have an instruction called return. So that means it will go back to the next line where actually it is start the subprogram. So then again, if we need the subprogram again, we say call this subprogram or subroutine or procedure, whatever it is, we come in and we'll come. So that means in a main program, we may have to use a set of program we may have to use again and again. So instead of writing this part, this subprogram, so instead of writing this subprogram here and here, so again and again, so it actually makes the things harder. So better to write it separately, because we have to use it again and again, more than once. So so we cannot, it's not wise, or it doesn't look good to write this subprogram in the main program again and again. So we can write it separately. Whenever we need it, we call it, and then we finish and back to the main program again. So this is called the concept of subprogram or subroutine or procedure. Okay. So, but what is macro? Okay. So one way, so this is actually repeating here. One way to write the group of instruction as a separate procedure or separate subprogram. We can then just call the procedure whenever we need to execute that group of instruction. A big advantage, what is the big advantage of using a procedure is that the machine code or binary code for the group of instruction in the procedure only have to be put in memory once. That means even though we are using the subprogram more than one time, many times, 2 times, 3 times, many times we are using, but machine code will be generated for one time. So that means you are not using the memory, you are not overusing the memory. But yeah, so this is but what is the disadvantage? Disadvantages of this procedure are the need for a stack, because like we have to we when actually call it, that means we have to save the return address in the stack. Okay, so otherwise you cannot come back. I mean, the microprocessor cannot come back to the main program again. So that means we have to use the stack to save the return address, and also push and pop. Using the push and pop, it needs some register value to be saved. So stack and the overhead time required to call the procedure and return to the calling program. So that means because you are jumping to the new location and then return back. So here actually some time is some time extra time is required, because during the jump cases it needs more time. So this is called the overhead time. The overhead time required to call the procedure and return to the main program, return to the calling program or main program where actually it is called. So this is actually all related to the procedure or subprogram. Is that clear to you? Do you understand? This what is called what is called subprogram or procedure, and what is the benefit of using writing the subprogram, and what is the disadvantage here? Any question do you have? So what about the other guys? Is it okay, the writing the subprogram? I mean, when, like, when we have to use a group of instruction or a set of instruction, we have to use again and again, like for example the delay subprogram. So when actually we can use the delay subprogram many times, because like when the red light on, we have so red light on, so it is on for example 15 seconds, then green light on in the traffic light. It is for example the 50 second. So whatever second, 50 second, 30 second, whatever, we have to use it again and again. So so it's the main main program is same, main sub program to provide the delay is same, but we can make it multiple, like 10 second, 15 second, whatever it is. We can do it just using the simple way. You have seen, you will see it in the lab. Okay, so so this delay subprogram, because we have to use it more than once, we can write it separately as a subprogram or as a procedure. And so what is the benefit of writing the subprogram is that the machine code for the group of instruction is produced once. So that means it occupies the memory less. And even though we are using it more than once, but machine code generate for this subprogram is once. But what is the disadvantage here? We have to use the stack, and there is an overhead time. There is an extra time required to call the subprogram and return back to the main program. Okay, so this is about the procedure or subprogram or subroutine. But what is macro? Macro is like a function, user defined function. Like if you compare it with the C programming, it is also group of instruction. When the required group of instruction is too short or not appropriate to be written as a procedure, we use a macro. A macro is a group of instruction. We bracket and give a name. Give a name to at the start of our program. Every time when we call the macro name in macro name in the program, the assembler will insert the group of instruction in the place where it is called. Here, the assembler generates the machine code for the group of instruction each time it is called. That means what is the difference here in macro? That we call a set of instruction. We may use it more than once, but the machine code for this group of instruction also will be how many times we are using it. So that means it's not like the macro, procedure. In a procedure, actually machine code for this group of instruction is produced for this group of the group of instruction written on the procedure. The machine code is produced once. Okay, the number of times the machine code produces once. But here in macro, if we use three times machine code will be produced. So let's see. Okay, so just hold on please, guys. Hello, assalamu alaikum. বলো। হ্যাঁ, আমি করছি, আমি এগুলোকে ওই যে প্রিন্ট করে নিছি, না হলে আসলে প্রিন্ট করে নিছি, তা না হলে আসলে মানে বেশি স্টুডেন্ট তো ওরা ওদের ধরো মানে কোথায় ভুলগুলো হচ্ছে এটা যদি ধরো আসে দেখতে চায় তো এটা ডিফিকাল্ট, না তা না হলে তো মনে থাকবে না অ্যাকচুয়ালি। ও আচ্ছা আচ্ছা, আমি ওইখানে তুমি ইন্ডিভিজুয়ালি আপলোড না রেসপন্স না করে সলিউশন ম্যাটেরিয়ালটা দিয়ে দিলে তাহলে ওরা বুঝতে পারবে। হ্যাঁ। হুম। হ্যাঁ, বাট এটা যদি আমরা ফার্দার ইউজ করি বড় অ্যাবেট বা এগুলো তো কাজে লাগবে। হুম। আচ্ছা, ঠিক আছে, ওকে। Okay, so how to define a procedure? This is already we I mean few lectures back we have seen it. Like we can write the name and we can we write the proc for procedure, and then attribute. Attribute is mean near and far. Can you remember we write it near and far? And then in the these are the instruction, and then name and np p for a procedure. So this is the way actually we can write our procedure, or we can write it a simple way also, like if you can see that I have seen it in the delay subprogram, okay, or the delay procedure. So I mean we do not write the name, just I mean, or we do not write prop, far, near, far, these are, but in general this is the format for the procedure: name, then prop, and then attribute. Attribute may be near or far, and then in the middle we have some instruction, then at the end we write the np, p for procedure. Okay, but what is the macro? How actually we write the macro? We write the name, then we write instead of proc, we write it in macro, and the parameter, the argument. I mean, yeah, yeah, the parameters like that we normally use in our function. Okay, so parameters, and then in the middle we have instruction, and then end m. End m means end of macro. So okay, let's see the example, more example about the macro. So like for example, we write the macro name is my macro, and then macro, and then the parameters are p1, p2, and p3. And what actually we are doing using this parameter, for example, move ax comma p1, move bx comma p2, cx comma p3. Okay, and then this is the end. So this is the macro. Okay, or function, our function. And then in the main program, and here is the main program. Okay, for example, this is the main program. We write org 10 and my macro 123, my macro 45dx. What does it mean? Okay, forget about this line, return. So that means in the main program we are using my macro is like a function. We are calling a function my macro 123. That means then what actually it will come? It will come to the my macro, the function that is defined. The name is my macro, and then here you write in the macro p1, p2, p3. Actually, that means p1 is assigned to 1. I mean 1 is assigned to p1, 2 is assigned to p2, and 3 is assigned to p3. So then that means move ax comma p1. So p1 is actually 1. So that means the ax value will be 1, bx value will be 2, cx value will be 3. But here, when we call again my macro 45dx, that means 4 will be loaded in P1, 5 will be loaded in P2, and dx will be loaded in P3. So dx value will be loaded in P3. So then AX comma P1 means actually AX will be loaded with 4, BX will be loaded with 5, and CX will be loaded with the DX value. Okay, so so basically what is happening in these two lines? What is happening in these two lines? So we are calling a function 2 times, and same function my macro. So 1, 2, 3, that means what will happen? AX will be 1, BX will be 2, and CX will be 3. It's like that. Okay, so this is like that. So we can write it in hexadecimal. So okay, I think here actually one more 0. I mean 0 is, it becomes one more time here. 0 0 0 1. Okay, BX will be 0 0 0 2. CX will be 0 0 0 3. Actually, okay. Now for the second time, what will happen? Again, AX value will be 4 or 0 0 0 4, and BX value will be 0 0 0 5, and CX will be DX. So that means it's like that. So instead of writing move AX comma 0 0 0 0 0 0 1 is, so we can define a macro. We can define a macro and we can call the macro like 1 time, 2 time, more time. Is it clear? Do you understand this one? I mean, what is macro? Or what macro is like a function, you can call the function like, in a C programming, for example, you can make the factorial, or you can make the square of something. So what actually you do, what is happening in the square, you can define it in the my macro, and then if you need 2 square, you can call it my macro 2. If you need a 5 square, you can write my macro 5, something like that. Then this is the way actually it works. Is that clear? Macro. So macro is like a function. Okay, macro is like a function. So like, if you can remember in a C program, you use like a factorial or a square or something like that. So that means you define the factorial, or I mean, or square or something, whatever it is, you define it in my macro. But in a main program, you can call this function many times. Like if you need a 2 square, you can call the function with just writing 2, and you can call, if you need a 5 square, you can call the function again writing 5, so on. This is the way actually. So that means this one is called this, I mean, macro. So macro, but what is the benefit of disadvantage here? That means disadvantage is, for example, here we are calling the my macro 2 times. So it means actually these 2 times actually are calling. So in every time actually we are doing 3 move operation. So this means this 3 move operation and this 3 move operation. The machine code for this this 3 of, I mean, 3 move operation here, 3 move operation. So all the machines. So these 2 lines actually, we are writing 2 lines in our main program, but it means actually 6 line, 6 move operation. The machine code related to the 6 move operation will be generated. So that means it actually taking the memory location more compared to the sub program. So compared to subprogram, because in a subprogram the machine code is generated once, but in a macro, the number of how many times we are using the macro, that number times, that many times the machine code will be generated. You get my point? The number of times we are calling the subprogram, I mean, we are calling the macro, the machine code will be generated that many times. Okay, so this is the, so that means when we need to use it, yeah, we may use it like a function. We may have to, so like a function, instead of writing it again and again, like here. So instead of writing this 6 line, this 3 line, we have to use it here, and we have to use it. So instead of writing the 6th line, we can define a macro, and we can in the main program we can call the function or call the macro. That's the thing. It's like a function, when actually we have to use the function. It helps us to make the things more user friendly, something like that. Yeah. So yeah, but what is the benefit here? So what was the disadvantage in yeah, yeah, I'm done. So what was the disadvantage is procedure? This is the benefit here. What was the disadvantage in a procedure? That was like it actually is overhead time is more there, but here the overhead time is less. This is the thing, because we have to use the stack, we have to use the, we have to use the, we have to jump to the sub program and then coming back here this is the way actually it takes long time, but here it doesn't happen. That's the benefit. Okay, so time is over. Until now it is okay, we are done.